All right, it's September 3rd, 2025. This is Active InferAnt Stream 15.1. Been a little bit, but we're back. We're in the start repo, start.activeinference.institute, and this should be a very fun multi-level stream. Right off the bat, this is where we're going to get through today. I'm running run.sh from the top of the repo, and several functionalities are shown, which we're going to go through. The first is the system checkup. The second is an environment setup step. The third is the generation of custom curriculum. This is going to use LLMs, generative AI, to write custom active inference onboarding curricula, depending on a given audience or entity, and then translate that into whatever language you want. And then the fourth option is the repository manager, where we will clone into a variety of repos. So I am going to get a few of those cooking. Welcome this fine evening. Looking forward to everyone's comments and questions. First, in this one, I'm going to get the repository cloning going, clone the available repositories, and get that going in the background. Then I'm going to open up another run.sh instance /run sh. On the second one, I'm going to start up a custom curriculum generator. As soon as somebody types in the live chat a given entity that they'd like to see, I'll add in another one as well. So let's get in there. We will go to 3, generate curricula. Initializing the epistemic and pragmatic aspects of consciousness. Connecting to the free energy principle. Okay, here we go. What this interactive curriculum generator gives us is some options, some interactive options for what kind of domain we want to do research into and what audience we want to tailor the material to and what language. So we'll start out with either entering an existing domain like physics, or we can add a new domain. This is going to be coffee tasting. Yes, it's a new domain. Target entities, we can pick a given entity. We'll go with Tulsi Gabbard, just as the first listed entity there. And then we can pick a target language. And we'll go with Ancient Greek. Okay, it's a new language. That's fine. Alright, coffee tasting, Tulsi Gabbard, Ancient Greek. Yes, proceed with that. Okay, while that's proceeding, check in on the cloning. This is going into the clones subfolder under SRC. And that is cloning into a variety of repos, some of which are explored in other streams, others which I've made some major updates to over the previous few days. So we're going to look into some in a little bit more detail. But let's pull back to this agenda. So, again, welcome. This is the start/here, a map, and what might happen next. There's a repo that goes along with this. Just expanded the browser window. This repo is at github.com/activeinferenceinstitute/start. And it is an advanced AI-powered system for creating personalized active inference and free energy principle curricula, and more, and much more. It's also connected with a documentation, local and cloud-hosted documentation strategy. So activeinferenceinstitute.github.io/start will give you some hosted documents. And also they will pop up locally. And some quick links are shown. To run the experience, you can do ./run.sh. That's what we did. Or let's open up another window and use the other top level run script, which is ./run _ docs. Oop. /run underscore docs. So what that's going to do is run the document checking and rendering, preparing any packages that are needed along the way, and then pop up here in the browser window is a locally rendered at IP address 127.0.0.1, port 8003. So this is the locally implemented server for documents, or you can look at the exact same material in the GitHub document pages. So we'll keep that in mind, and we'll kill the doc runner. Okay. Just crashed. Okay, we're back. Oop. Okay. We're back. All right. So we're live in the stream. I look forward to anyone's comments, and let's just go over what is going to happen. First, what is the start here repo? Well, this is just to get it out in an InferAnt stream and show a little bit of the behind the scenes. But this repo, broadly speaking, gives an interactive and well-linked landing page into the active inference ecosystem and institute. Now, elsewhere, we have some welcome page that has a lot more interactive material and a lot of hyperlinks to our living document, but there isn't any code execution in Coda. So what I've been working on is this start repo, which has a little bit more of a seamless experience in terms of not just linking to resources, but actually making a repo that runs them. So this repo gives a fun, interactive, matrix-themed landing page into the Institute and ecosystem. It renders, as we've seen, into local documentation as well as updated GitHub pages. It uses generative AI to write custom curriculum. We'll see if that worked. That looks like it's still going. And it also helps us clone and deploy repositories. So, for example, what we have cloned while that was all happening is activeinference.jl, which I have made a fork and some modifications to. Axiom, which is the recent open source architecture by Verses. Cerebrum, which is the linguistic approach to modeling case systems and other linguistic aspects in models. The cognitive repo, which is a large underlying Obsidian formatted markdown knowledge repository that you can open up with Foam or in Obsidian. Generalized notation, GNN, for notation and metaprogramming with generative models. Lean Niche, which has been a bit of a fun collaboration with Jason Larkin, and we've been using the Lean Theorem Prover to explore a few aspects of probabilistic dynamical systems in the FEP. PyMDP, which I've made some heavy modifications to that we'll go through. RxInfer examples, also a fork of which I've heavily modified. And template repo, which is a repo for setting up a scientific paper rendering pipeline involving code and figures and equations and all that. So this is just an example. You can add more repos that get cloned in, but Start is hosting all of these different repositories as options to download in. So those repos just mentioned, and many other implementations exist, can help bring together open source implementation type frameworks like PyMDP, active.jl, rxinfer.jl, Axiom, etc., and all kinds of emerging tools, be they related to synthetic intelligence, LLM, etc., and also anything that you want to bring in terms of adding in another custom repo, or just having another repo in this clones folder. Attack of the clones! So, that is a cool setup, landing page, Nexus. There's a few themes and ideas that I think we'll revisit, but what I will do next is look at these themes, get a first pass on the themes. Then we will look at some of this custom generated curriculum material. Then we will turn to the PyMDP and active.jl forks, where I have made the most of the modifications. So, themes and ideas. Start here now, or act in first serve, whatever you prefer. Just jumping in. Active is about action and perception. It's about inbound, outbound, about joint distributions for agents and niche, grip or gripped, duck rabbit, all this kind of stuff that we're always talking about. And in our own learning and application and contribution journeys, we just start here now, or there now, or then, if that's a better one. But it is about doing, it is about starting where and how you are, not waiting for something else to be the case, unless that's where and how you are. Cartographic pluralism. The name of the stream is a map, not the map. It is a map. It's not the only map. It's going to version even during this stream. And also cartographic realism, cognitive realism, open source intelligence, ecosystems. And we're talking about ecosystems that we're mapping the ecosystem in terms of sharing links and resources and signposts. So we're mapping the ecosystem of maps of minds, like mice, people, ant colonies, LLM, that map minds, or not. Might map another mind there, or it could just map something. We're mapping the ecosystem of maps of minds, generative models, that do mapping. There are multiple implementation frameworks for active inference. There are many ways to build up along the low road. We see that just by the juxtaposition of all of these implementation frameworks right here. And with GNN, we'll even have each of them implementing, where possible, some of the exact same models and state spaces. So even for a given state space, there might be one or more accessible ways to implement it with different trade-offs. So implementations do not negate each other in active inference. Shipping the docs and docking the shipment, whether we approach this from a vibe coding or kind of developer perspective, or just the relationship between making sure that we're documented all along the way and documenting what we ship and shipping the docs, and this idea of notes to navigation and the ways to include the things that we're noting along the way in our field work and get through some really dense sites in one sitting. Okay. Clone the repos. Let's close that window. All right. Let's exit the matrix. So the generated content there is in the learning data. So the domain research. Here's the coffee tasting research. That was using Perplexity. I will push this to GitHub just so we can look at this a little bit in a rendered form. Data. Here was InferAnt Stream 8.1. That was from December 15th, 2024. And that was it was 8.1. Symbols Greetings. And that was the first iteration of the start repo. Okay, so here's the audience research. Here's the Tulsi Gabbard. We also have that domain research with the coffee tasting research. And then here's the written curriculum. Here's the Tulsi Gabbard curriculum. Here's the complete Tulsi curriculum. So it includes a little bit of information on the person's background, their motivation, what kinds of core materials we're going to share with them, what kinds of assessments, how to connect it to the person's background. So this is just a starting point for, of course, that person, or for any person, or for the system that generates it. But it gives some really fun and exciting starting points. So let's see, a little William Blake background. Again, it's to be discussed, explored, played with. How much do you want to meet William Blake where he's at versus just have a sort of attractor that isn't personalized? So it's not that there's a, oh wow, look at this gibberish part. Incredible. Then we have the translations. So that is in translated curriculum. It looks like the translation stage is pretty slow. I didn't run it by default, but we can see that there's these translations of coffee roasting and so on. Okay. Here we go. Starting to look a little bit at the live chats by way of... Oh, it's still writing the... Still writing some of the material. Okay. So, let's go to some of the live chats. Okay. So, Dean. Hello, Dean. Wrote, I have no technical background with any of these repos, but I do want to take advantage of the curriculum generator. What's my first step? Do I need to learn have priors with ActInf? No, you don't need to have priors with ActInf. You need to have it just, this is this starting point. Clone this repo start. Find out from help or AI or videos how to use GitHub. Clone the repo. Go to the environment example file, copy it into a file called .env. That just, and then add in the real env, which is your secret file, add in the API keys for at least Perplexity and OpenRouter. Then, top level of the repo, /run.sh. This is going to go through these setup phase. This is not a loading screen. And we can put different custom messages there. I wouldn't say it's overly dramatic. Okay, then when it pops up, here we are in that interactive terminal. 3, generate curricula. So we'll just get this chugging along because it'll take a little bit in the background while we address the other one of your comments, Dean, and look at some of the repos themselves. Okay, select domain. Let's do island navigation using boat. Yes. New domain. Target entity. This is it could be skipped, or you can come up with another entity. I'll do Bill Gates. Create it as a new entity. Employee at Microsoft, and we'll just call him a common character. Target language, and here we'll do Ancient Latin. Yes, create that new one. Proceed. All right. So that's all that takes. and a little bit of time to generate a new curriculum. And this is just the version that we have today. So future versions, you can imagine a graphical interface, or we can even make that right now. So here, add another script in this folder called generate curriculum GUI, which pops up a simple browser window with the same fields and information as the interactive terminal one, yielding a GUI for custom active inference curriculum generation. And then while it is working, it says working with status bar estimate, and then when final results are ready, it shows them in GUI. Thanks, GPT-5. All right, so we have the Bill Gates curriculum developing in the background. And meanwhile, I'm going to quickly review a few of these forks of cloned repos that I've been working on over the last few days. And we'll keep an eye out on anyone's comments, questions in the live chat. All right, so here we go. Well, there's several interesting ones. They're all very interesting. But I want to show mainly the PyMDP. So this is all within this PyMDP fork. And just to show where this is in the browser, this is the doxology, so my personal GitHub account fork of PyMDP. And the branch is called textbook. So all that information is open source available. Okay, but here we'll look at it through the interface of Start. Opened up in Cursor, and we are in Cursor 1.59. Okay, so a couple of modifications and things in this textbook. First is the examples from PyMDP, which is just a copy over from the examples like the agent demo and grid world, copy it over in their most minimal form. And then the examples from PyMDP _ modified, which is where modified versions of the scripts are made that output more data and more visualizations than the notebook forms do. So if you want to, and the output of all of the scripts are run there. So purely just for getting a better handle on the PyMDP examples and to understand what they look like, that examples from PyMDP modified is pretty cool, pretty useful, very open to further developments that people can do in, of course, the PyMDP examples in the underlying repo or their own forks, or improving and making these examples more flexible. But the examples, so just examples, is where I have made 12 new examples. They get run by this script called runall. So runall.sh will run these 12 scripts, and here are the outputs. So this is about to be like a rapid review, kind of like the 2022 Pardal textbook, that brings together the fundamentals of probability and the Bayes rule in Module 1 and 2. Then Module 3, 4, 5, and 6 are related to sense-making and perception. Module 7, 8, and 9 are about active inference, policy inference. And then examples 10, 11, 12 are relating to the POMDP, the partially observable Markov decision process. So here's what the outputs look like. Starting from 1. Probability basics. This is going to talk about a few different distribution types. So here's a categorical distribution on the top, 3 discretely different options, the Gaussian or normal distribution in the center row, and then a Poisson or a rate parameterized distribution on the bottom, and each of those are shown in 3 different forms in terms of 3 different parameterizations. So it's like categorical. You're talking about things that differ discretely, and all of them across the categories sum to 1, and that could be like a third, a third, a third, or it could be bimodal, or it could be peaked. Gaussian, you can move around on the x-axis, or you can make it narrower or wider. That's variance or precision. And then this is a few of the different lambda parameterizations of the Poisson. In Module 2, Bayes rule, this is a summary of the information gain and variational free energy for 2 different settings. The first setting is the classic medical diagnosis setting, where there's a prior belief about how likely a disease is to be present, which could be the population overall frequency, or could be some other prior belief. And then there's a test which has a 90% sensitivity, true positive, and a 95% specificity, true negative. And so when you get a positive test, conditioned upon the observation of a positive test, not to overly simplify, but the frequentist says, 90 or 95% that the person has the disease, because that's what the accuracy of the test is, so that's what the most likely outcome is. Whereas here with the Bayes, we can see, well, depending on your prior, that's going to update what happens when you update after the posterior. So that's shown here. And then in the sequential example is weather, where you don't know whether it is raining or not. I guess you're trapped inside of a bunker or something, and you're just seeing whether umbrellas or no umbrellas are going with people walking by. And so you have an initial prior, 70% likely to be sunny, and then you see sequences of umbrellas or not. So that's kind of background statistics, good info to know. Module 3, and the sort of cousin of 3, refactored 3. These have to do with observation models in PyMDP. So these are ways, sometimes called the A matrix or the ambiguity matrix, where you have the mapping between observations and latent states. And that can be like the identity matrix, which is to say a noiseless perfect mapping. So basically just like a Markov decision process, not a partially observable MDP. Or different levels of noise, off-diagonal, symmetric matrices, all these different things. State inference uses the infer.states method of PyMDP to use variational methods to update priors into posteriors given observations. Sequential inference in the 5th module is a little bit more about different patterns of sequential evidence accumulation, which is worth going into. So, for example, initially, we have a uniform prior over latent state A, B, or C, 1/3 each. First time step, we see observation 0. This updates our belief that it's 80, 15.5. Second observation time step comes in. It's 0 again. We increase our posterior belief from 0.8 to 0.96. Then, third observation coming in, observation 1. So then that goes from 0.03 to 0.22. And for each of these, we can calculate the information gain per update. We can look at the components of the variational free energy. We can look at the validation of the normalization in PyMDP. That's 5. 6 is a beginning point for a multi-factor example. So here there's 2 independent factors. There's the weather and the location. So 3 possible locations, 2 options for the weather factor. And then that sets up 6 possibilities, and so there's different beliefs over joint states. Okay, so that's getting through the sense-making stuff. 7, 8, 9 are about action inference. So 7 gets you a little bit familiar with the B matrix, or the transition matrix, in terms of it being modeling from to latent states. But no action selection yet. 8 is going to go into action selection using preferences and pragmatic value in the expected free energy. So this setting, there are 3 different options for location: left, center, and right. The C, or the preference variable, is set so that the left has a negative preference, it's disfavorable, the center is neutral, and the right has a positive preference value. And then we can see how, conditioned upon your starting state, different moves have different pragmatic value. Here, the epistemic value is 0 for all. And then we can see how softmax over the negative expected free energy yields updated action posterior probabilities that get sampled from the same action prior, which is the habit, or the E matrix. So, for example, if you're starting in the left state, then move left, which in this situation keeps you in the left, or stay. They lead to the same expected outcome observation, so they are equally likely to be selected, whereas right has a higher preference, 0, higher than -2. So that has a higher, it's more expected to be the case. This is how we get preference and goal-oriented behavior without a reward distribution or reinforcement learning to training data, is we have things do what they expect. They change their mind and change the world to observe what they expect. Here, starting in the center, it's especially disfavored to go to the left, somewhat disfavored to stay, highly favored to go right, and then for starting in the right position, we see that there's, again, the same normalized probability of selecting either moving right, which is staying, or staying, which is analogous to the starting on the left situation and staying left. So that is the 8th module, which gets in, and also this is a separate one in 8, talking about like different preference distributions for the sweet lover and the health conscious taster. TM1Tap wrote, WTF is going on here, and why is it recommended to me? Yeah. Let me know when you find out. Okay, 9th module is a similar example where I don't think the coloration on the heat maps is all perfect. The epistemic status of all of this is functional and improvable. So I'm sure you and our synthetic intelligent viewers will find many places to improve. Please make that contribution, make that GitHub request. So here we're in a situation where there's 4 states, and the left 3 are equally neutrally preferable, and the right state is preferable. So then we can see that just from reactive planning, we rarely end up with a reward, but if we're able to plan and look ahead, we can. It's just a trivial example, but it's just demonstrating how the expected free energy is used for pragmatic value. And then 10, 11, 12 go through the POMDP example and shows the matrices and how that state space gets set up, and then how beliefs evolve through time, what action and observation sequences happen. 10 is the T-maze setting. 11 is the grid world, some blank visualizations there. Grid world setting. And 12 is another T-maze with a bit more and different information. So that is intended to be a useful resources. Again, that's the doxology fork of the PyMDP repo textbook folder examples are the 12 examples that I wrote up, with help, obviously. And then the examples from PyMDP modified, if you want to stick closer to the general purpose examples in PyMDP, then those are the ones to go with. Okay? Let's see how the okay. Let's go over to the updates in ActiveInference.jl. So ActiveInf.jl, here, this is a Julia-based package, and I have also made a textbook branch and subfolder. So in this case, there are 5 examples, so it's structured a little bit differently. The first example has to do with the mathematical foundations. Second example, this is just just a slightly different learning path. Second module has to do with the variational free energy. Third example, expected free energy. Fourth example is going to use the POMDP. Fifth example, hierarchical inference and multi-agent coordination. And here's what the outputs look like. So first, the foundations. That curriculum generation is still happening in the background. It's pretty slow. Okay, so here's from the foundations module in the active.jl repo fork. Pretty old computer I'm running it from, Pop OS. Okay, maybe it'll be better to... Let's look at it within the browser. Textbook. Output. Okay. So, there's the information theory. So here we have 4 different distributions. Observation comes in, and then we have KL divergences calculated. I'll just do it here. VFE, the seconds unit. Yeah. A little slow, but c'est la vie. Like, it's faster to load it through GitHub than to load it in the IDE. Tragic. Here is the VFE perceptual inference, state inference process. We'll just let that one load, okay? Similar examples in the EFE module. We have analogous examples for the EFE, and same as the POMDP and the multi-agent. So kind of fun. And then we'll look at the multi-agent trajectory. Okay, we'll get this. Yeah, here we go. So this is a multi-agent grid world. Metagrid is probably a better framework for doing this kind of collective foraging multi-agents situation. I'll just bring that up in the browser. Yeah, David Blumen et al. Metagrid is better if you actually want to make like these kind of role-playing game meets collective foraging, multi-agent, flexible, active reinforcement learning settings. Okay, here we go. Now the GUI has popped up. So this was again prompted, just that was a two-shot prompt. First just said make a GUI for what does the same thing as the typing. So let's domain, nursing, entity, Elon Musk, language, Russian. So there we go. All right. Just to close off there, if you really want to do a multi-agent setting and you want something that's really professional, Metagrid or some other option is probably a better choice. But the whole point of what's happening here is we can look at the expected free energy values and posterior beliefs and all this kind of stuff, and we can connect with how we learn and apply these implementation frameworks. Okay, so that worked. All right, now I'm going to return to Dean's previous questions and his new one. So yeah, if anyone else has any ideas or questions, or they want to see something happen. Okay. Whose map am I building? Whose map am I building? The curriculum that modifies a current mind model. So a map outside both the curriculum designer and the curriculum subject. Is the limit of my self-organization my ability to generate effective prompts? It seems like I'm giving most of the organization tasks over to the processing agent, which isn't me. True? And then you wrote, I see the AI generating and organizing. Shouldn't I practice these tasks too? Yeah, these are huge questions. They're definitely things that I've been thinking about over these last few days, working on it. Let me have a sip of water, and I'll think about what tack to enter here. Shouldn't you practice those tasks too? Well, to the extent that we're going to be normative here, pedagogically, yeah, I think that you should, one should, I should, etc., generate and organize. And while the AI is doing a lot of the terminal generating and organizing in terms of writing the actual curriculum itself, first off, those are just intended to be intermediate artifacts produced for curation and secondary refinement. So it's not that it's generating the final word. It's generating a blob of clay that might be close or far from your vision. And it is organizing things in a way that has to be quite strongly typed in order to find to use the entity research on some data. To use the entity research on Barry Bonds, yes, it has to be organized into the right fields and all of that. But there's a higher level organization that is organizing that kind of syntactic organization. And then there's the syntax and the semantics of generating these systems that do this thing. And that is its own kind of spring training practice. Is the limit of my self-organization my ability to generate effective prompts? Yeah, there's a lot of layers to look at that question at. In some ways, you can ask for an effective prompt you can ask for a kind of prompt, like write a good prompt for doing this. And that's like off-sourcing more of your exact semantics in exchange for what might yield a more compliant output, especially structurally, but only you are going to be able to generate what you can do. However, aren't we seeing that with even a few words or an image? It's possible to mimic quite well. It seems like I'm giving most of the organization tasks over to the processing agent, which isn't me. Yeah, I think that, well, at first I wonder, to what extent was that thought in the calculator days, or in the steam engine days, or in the early automobile days, or the video recorder days, or the Excel early days, or whatever it is. We are doing different things. Okay, is the limit of my self-organization my ability to generate effective prompts? Short answer, no. Prompt skill helps, but the ceiling on self-organization is set more by your systems than by phrasing alone. How do you raise the ceiling? Define artifacts plus DoD, probably not that one, but interesting. Add tight loops, use scaffolds, externalize context, that's kind of the context engineering angle. Stable interfaces, automate verification. Prompts are one lever in that system, useful but not the limiting factor. Huh. Bill Gates' SAT score. Yes. The GUI's still plugging away. Metagrid for multi-agent. Translations into custom languages. Local and GitHub documents for a lot of machine readability, and we can translate these documents into other languages as well. Okay, then just briefly, the last of the implementation framework where I've been adding a lot of work is in the SRC clones. Oh, it didn't clone RxInfer. I'll just show it in the browser. Here in the research folder on my branch, or my fork of RxInfer examples, are several fun methods related to RxInfer. Generalized coordinates, hierarchical Gaussian filter, integration with LLM, the POMDP, the infinite data stream situation, visualization methods, and then here's one that I will show, which is the manim package. So, people may be familiar with the 3 blue, 1 brown math education channel, who makes videos like this. And there's a open source package called manim. And so I use the manim package to go through all of the RxInfer examples. So it's like we have this kind of like mini documentary, procedurally generated starting point for each of the models in RxInfer. So there's 2 different styles of model. One of them is going to have a, I'm just picking 2 random examples. There's the drone. There's the source code. That's just going to have this like source code kind of pop up on screen, and then there's the dot graph. So it's not going to display in the, but it's a good starting point. So extra usable setup utilities and examples in ActiveJL, RxInfer.jl, and in PyMDP. Recapitulating the examples in those repos and adding these textbook folders And each of those are just cloned subrepos within this start repo. The start repo has the ability to generate more materials like we're seeing. And then also it has this start here.md. So the idea is, welcome. This is a simple, actionable landing page into the Active Inference ecosystem and institute centered on this repository. If you only read one file to begin, make it this one. Why this repo exists. Learning by doing. Generate, visualize, and translate curriculum content grounded in real data. Build end-to-end. No mocks, real I/O, reproducible scripts, and tests. And contribute to the ecosystem. Improve docs, scripts, and learning materials for the broader community. Here's a bunch of links. The Obsidian link is the live sync version of the cognitive repo. So if you want to play around in this kind of knowledge graph, that's the cognitive repo. You can just clone it in, open it locally. This here.md talks about a few things you can do with the repo, and then talks about how you set up the repo with the UV package manager and run the run docs and the run. Also just a starting point, but gets a lot of it there. And you can always go to Welcome or Obsidian for that kind of multimedia linked living document style. And however, I think that the start repo is filling a critical service and role in the open source ecosystem, which is this kind of meta repository management, having set up scripts that install UV. If you don't have it, then use UV to set up the environment, and then use that setup environment to clone repos, forks of those repos which themselves have setup scripts. And so like here's the setup.sh within the PyMDP fork. So by running this sequence of setup scripts, you will go from either a click or just one line entered into this cloned repo all the way on through having checked files that run and do different aspects that are important for understanding conceptually and building an active inference. So here's the Axiom repo by verses. And then we can just go right in there and just say, okay, run the Axiom repo right from here. I have a private fork of Axiom as well, but this is just, let's just see what happens with one-shotting it here. Okay, so talked about the repo, about how it can generate material, talked about a few of these implementation strategies, covered up for these three, PyMDP, ActiveJL, RxInferJL, about the forks that I have been working on that are facilitating setup and examples. For a later date, maybe, with the GNN lean niche Cerebrum. And I think it takes us right up to the edge. So, just for that one line. Now we are running Axiom. So it's playing that video game Explode. I don't know what that is. But it's a video game. And that's the beauty of when a repository has its own setup materials and reproducibility, now we can just clone Axiom and run it. So like, so many cool ways to compose across repos, cross-render in and out of repos, public repos, private repos. There's RX Infer examples with neural networks, a lot of work across different repos in LLMs and other AI methods. So for those who are curious or soon to be curious about how do you learn and apply synthetic intelligence in active inference, that's why we have a map. /here. And then feedback along the way. Just what parts were challenging, which parts were awesome, what you like, where did you get held up? Did you like being held up? Where would you have wanted something different? And then either raise your hand and give the feedback, or reduce your uncertainty by making that change yourself and figure out how to fix it on your own local version, and you'll be contributing to open source software in no time. Okay, let's see how that educational material went while Axiom is running. We'll do it through GitHub. Okay, just pushing it. All right. Thank you, Dean. Oh, it's in data. It used to be in the learning folder. Okay. Audience research. Translated curriculum, visual up. We'll just look at it in the browser. Translated. Okay. Here's the, from 1 minute ago, ancient Greek. So here's the myrmecology curriculum for active inference translated into ancient Greek. I will leave it to a speaker or reader to evaluate. Here's the audience research as a JSON. And then here's the written curriculum for those domains and entities. So let's see, we have the Elon Musk and the island navigation using boat. Then I'll just see if there's any last comments, otherwise that'll be it. Okay. Again, we can update the prompts, we can have mermaid diagrams, we could have more links, we can base it off of whatever material is put into synthetic FEP active. This is the material that's used to generate, so that can be versioned. And yes, careers and educational foundations in island navigation. Wow. Perplexity or OpenRouter, I don't know which one of them is yielding it. Probably the OpenRouter. Look at some of these. I think it's using like the Llama Scout 4 or something like that. But whoa. As recorded, class expenses valued everyone machine. Gron Blind likewise quotes request conscious integrity, understand, entered podcast associate straw credential. Chol kept hypotheses, streamline incidents, near longitude, acquainted dissipicant. Approach cult soil permitting, utilize sense modification. Deterview replication, planner, legal, culti. Alright. I'll just wait 1 minute unless anyone has a final comment or question. As usual, I hope this is interesting or fun for you. I put all of these out in the open source spirit for people's feedback, their commenting, their engagement. There's a lot of fractal ways to contribute. You could make your own repo, and then we can have it clone in. Or you could make a pull request or raise an issue right here in the repo. So that is all for tonight. I will leave to you to do the who's on first and all of the dramatic readings and everything. Just wanted to get that out there. Hope that this is a place where you can say, where should I go? Where do I return? And we can make these links accessible, rigorous, applicable. So, thanks for watching along, and enjoy.